And we are live. Let's wait until I get the feedback from YouTube to see if everything works well and if the audio is there. The delay is only about 30 seconds. Yep, I hear myself. So the audio should be fine. So now, I just wanted to get a bit of distraction and to do something. Well, it is still, I'm not sure if it's electronics, but it is electric, and it is a bit of hacking. So I got this thing as a gift. This is, let's move the cat away for now. Oh, let's move the cat somewhere where it's still visible on the camera, so I know if the camera hangs or not. Just there. So this is a bread baking machine. So you simply put your ingredients here and then it cooks it and it makes bread. Generally I do make bread myself, also with custom yeast, but I make it in the oven. But I still wanted to test out how this is. Bread is less good, but it is a lot easier to make. So the machine have a purpose. They make bread making a lot easier. The issue with this machine is that as soon as I switch it on, the fuses in my apartment blow. So there is and what trips is the RCD or CFGI in the US. It means that there's an earth leakage. Something from live or neutral is going to earth, and this is detected by the CFGAs, and so you don't electrocute yourself. It switches off the complete power. And today I want to troubleshoot this. So we'll just open the device and see what it is. And actually I can show you. So let's hope it works. Because if now I trip my energy source, then the stream will be completely gone and you won't see anything anymore. But I have this device. In one of the previous streams, I showed how I built a quick tester, which allows you to, you plug anything in here. And what is this? That's the remaining. Oh, why do I have this? I don't remember. So, it comes from here. So you plug anything in here, and in this case, I just have a socket, and you press on and as long as you keep pressing on, there is power going in. And the advantage of having the quick tester is as soon as I stop touching it, it switches off. So whatever happens to me, if I have an issue and can't touch the thing anymore, power is off. So this is good. We have a volt and ampere meter, and we have individual fuses which we can set to whatever we want. So these are glass fuses, and here we have resettable main fuses. So these are 10 amperes. These are the largest one. I don't allow more than 10 amperes, but we're using the 2 glass fuses in here. You can restrict the power if you want to do some tests. I think here it's still 10 amperes also, so yeah, it's okay. And I have it on both sides, on live and neutral. Normally one should be sufficient, but just to be sure, I always have on both sides, because I could. And what also it has is this thing, and this is actually an RCD. So this trips at, I think it's 10 milliamps. It is 10, it's probably super hard to see because it's white on white, even with the bare eye and the right lighting. It's hard to see, but here it says 10 milliamps. So the 10 milliamps is a bit less than the 30 milliamps I have in my electric cabinet, which blows the fuse. So the 10 milliamp, it doesn't mean that it will trip earlier. It means that it trips with less current. Generally, with less current, it trips earlier. So I have a 30 milliamp in the power box, which trips. This is a 10 milliamps. Let's see if this trips before the mains trip. The mains thing trips. So here we have power. And here we see we have incoming power, no energy usage. If I plug this here and if I switch it on, we should see that this switches off if we are fine because this should trip earlier, or at least this is what I hope. So let's try. So okay, it is switched on. So the device is switched on, but it is not powered yet. If now I press power, now there is power and now it works. And it doesn't trip. Why doesn't it trip? That's not good because it should trip. Maybe, I know. Now it's just turning the motor, it's not switching on the heating elements. And the issue I had when I tried the machine is it broke when the switching element went on. I don't want to touch it because last time it had an earth leakage, and normally here earth should be fine. The earth is connected to the middle, so that should be fine, but why doesn't it start? Can't I have please don't turn but switch heating on? Let's see in the inside. I think now it's just turning the motor. It's not even doing that. It's trying to turn the motor, but it doesn't work. You see how it tries to turn the motor. So there's this thing, well, it has a huge issue. Let's switch it off. And let's try if actually Earth is really connected to Earth. Because this thing should trip. So, continuity test. This Earth is connected to this one. Yes. So Earth is going through, so at least this is secure. But the RCD doesn't need Earth, actually. The RCD just measures the difference between live and neutral, and if the difference is more than 10 milliamps, it should trip. So even if I don't have Earth, I should be fine. This thing should still work, but there is Earth, meaning that no matter what happens, at least it works. But no. Yeah, it should also work with Earth, because even if the Earth is not connected here, if you touch it, you are becoming Earth. So let's test this thing. So now the demo effect is completely blown because it doesn't work. It didn't trip, but it did trip. That is why I put it to the side. And now I don't know why it won't trip anymore. But also it wasn't able to turn the motor, so we clearly have an indication that something wrong is going on. Can I have, well, this small camera, the bench camera is more useful. Screen replay, no, I don't have a bench which shows the whole thing, no. Okay, let's try again. Oh, this is something bad. As soon as I switched on, this machine started turning the thing. I think it remembers what it did last and it tries to continue. This is not a good thing. A device, when it plugged in, shouldn't be able to start immediately the cooking. Yeah, it is. There's the red light on and you see that, well, you don't see too much, but I hear it and I see that there's a small wiggling inside here. So let's switch off. Small wiggling, so no, and it isn't able to turn the motor. So there's something completely wrong with this machine. I don't think I will use it. I make bread also with a normal oven, so I probably won't use this machine. We'll disassemble and see what's going on. Okay, now I switch on. Yeah, it tried to turn the motor and it's not able to. And there's nothing blocking. So if there's dough inside here, it should be even more blocking. So the motor not turning indicates that there's an issue, and there was an issue. So yeah, let's just take it apart and see what's inside. But I'm surprised that it didn't blow the fuse. There's still something wrong. And I wasn't able to test. I did test it once, so I know that this trips before the 30 milliamps of the main breaker. Probably it doesn't do all the time, but with this machine it did it. And the quick tester is a good thing for that. So let's just open this huge machine. Probably I will just keep the motor and nothing else. Okay, there are two security screws. and three normal screws, two security screws under the feet. Are this? No, I don't think there is. If there's something in here, so let's get up. Gloves and let's open the device. Where are all my bits? I do have a huge bit tray normally. Where is my bit tray? Is it here? Yeah. You don't see what I'm doing because it's in the back. It should be here. Yes, it is. Screwdriver. Let's just use a hand screwdriver. Should be fine for now. Here, a collection of bits, and there should be one which should work with what we need. So they are not really quality bits. They are really crappy, not resistive, but to open most devices, it's plenty sufficient. Up. And by hand, if you don't use an electric screwdriver, if you do it by hand, you can somehow better control the force and the speed, so you don't break the bits even if they're really bad. So up. Let's use this tray to put the screws where they were. And remember, although I probably won't even close the device anymore. Quality passed. Yeah, you generally do it on a screw, so you know if somebody opened the device or not. And this sticker here, this should be also on a screw. Can I switch the camera? Because the small camera isn't useful at all, at least not for now. So you see everything on a tiny camera. Okay, let me drag this one because it's the most important one. Up, and let's switch off this. Okay, now you can see a bit more. Okay, these are the two screws, and then we have the bigger screws. These ones. One. And I wanted to do it today because I want to get rid of it. It just takes too much space. And I try not to hold too many things. Let's use a spacer. Okay. Did I unscrew this one? Yes, I did. Let's magnetize the thing. Okay. The screws are not magnetic. Okay, it's hard to get under, so they are not only screws, but they're probably tabs somewhere. Damn it. Alright. Pry this device open. Maybe there are really screws under these feet. No, they're not. And there's no screw under the sticker, so it should be fine. Yes, I have other spudges. What is holding it back? Apparently there's not more in it. Screws. I don't. Here is a tab, I think. Yep. So there are tabs. I even broke a tab. Maybe I should lift it so it's not the bottom which should be lifted, because everything is tied to the bottom, but the top that should be lifted. Let's try it this way around. Let's remove this piece. How is this put together? Here there's screws. I just want to open the bottom. I don't want to open the hole. Yeah. And there must be other screws, it's just too hard to open. Do we want to do it correctly? Well, at least it's well built in this sense. Let's try it on without the tray in the middle to see if it tries to turn the motor. Let's switch it on. Okay. Okay, so now I switch it off. Now I switch it on. Yeah, it doesn't even try to... it does try to turn the motor a tiny bit. It doesn't have the force. Although it should have the force, because it should be a strong motor. There are screws here. Are these screws tied to the bottom? That might be the case. Or are they just holding the side? We'll have to find out. No, the heating element didn't turn on. Up. I wanted to salvage the motor, because it's only a motor, a heating element, and that's basically it. There's nothing more, it's just a timer. But the problem with the heating, I don't need the heating element for anything, and the motor seems to be busted, so I'm not even sure if I could salvage this one. Yeah, this is probably just for the metal piece. Let's still open it, because else I don't have any idea how to open this device. Okay, this screwdriver is too large. Let's try with a smaller one. Well, for the screw it's ideal, but it doesn't fit the side of the pen. I don't know. They must have super long screwdrivers to screw these things. This should not be easable to screw on. Okay. And these are threaded, well, screws. They are not self-tappers, so they don't turn in plastic, they turn in metal. So it's probably a metal base. I can't turn it. No, I don't have enough power in my fingers. Do I have a super long? No, I don't have any super long thing. Ideally, I would remove the heating elements, but this must come before the heating element. I know how they could have done it. Using a square thing. That might be the case. I should have one too. Let's try if it works this way. Up. Maybe. So yeah. these kinds of things where when you turn on one side, it turns the other side. Does it fit here? Yes, it fits. So let's try. Screw. So this is a rather boring part, but it must be done. Ugh. Even with that, it's just too narrow. No, it doesn't really work. Nope. Okay, it was an idea. Maybe this way? No, it's still not long enough, so they must have super parts. And I probably won't have the force if I use this. Oh, it doesn't fit. Now it must be straight from the top. Okay. This is probably irrecoverable. No, yeah. Yeah, this must be lifted before. So they must have super long screwdrivers. And yes, you can probably hear it on the background. There is some building in my building, so it's loud. But this bit is going on for months, so there's nothing I can do except wait. Yeah, you can hear it in the background. My microphone picks it up. I see it on the view meter. I don't have the force to turn it when it's here. Now I should have the force to turn it. I have the force to break the plastic. Okay. That was the initial one. Yeah, this is not going back to get back again. And I think one of these things costs something like 50 euros. This seems to be rather basic. No, nothing fancy. So no, this will not come back together. But I still love tearing things apart. It's good that it doesn't have to come back together. So I don't have to be careful. We can break everything we want. Up. This screw will be a pain. I hate this one. Okay. This was here. This is here. This is here. Last screw for the inside. No, I don't have the force. Okay. Yep. Strong connection, that's for sure. Actually, I could move the camera. No, now you see everything. It's fine. So now I should be able to lift this. I have to unscrew this. It's holding it back. I'm not sure why they use the ceramic element instead of not metal, because you don't want this to heat, you just want the inside to heat. So you use a ceramic element for thermal insulation, and it can hold a lot of heat. And the screw is super long. Okay. There's a second screw. But it's just to hold the ceramic element. It's not to hold the metal piece. So let's lift this. Is there no earth connection? Okay, the screws would have made the earth connection. Yeah. The earth connection is not done. It is done through the metal. Unscrew. No. I'm only breaking it. So. Okay. Now it's definitely broken. I have no idea how they screwed afterwards, but the screws are... I already broke the screw, they're super chintzy quality. Up, so the inside, yeah. 1, 2, no, there's nothing holding it. Here there are tabs, yep. We see the plastic tabs now. And that's what we heard, yeah. They're just plastic tabs. Up. Let's remove this connector. We must have open it, because I can't remove the connector without and lift everything up. And that's the inside. So here we have phenolic, I think FR1, just one-sided PCB material. Although it could be FR4, no, I don't know. So, but here we have the circuit just for the display and the buttons. There's no microcontroller. This goes with this ribbon cable to the thing inside here. And yeah, there's not a lot in... Whoa. Now I can switch the camera. The screws are not important anymore, because I won't close the device. Don't want to use it. What is this? What is this? So, what is this? This is huge. This is the motor. Let's switch to it now. Let's place this back in, and let's switch back to the camera, where you can have a closer view instead of the overview camera. No, this one. Here we can switch this again. So if I'm measuring something, you can see it. Can I switch it on without the thing in the front? Does it detect that it is missing and will complain? We will test it. So I have gloves, but I should still be aware that this is powered. So let's switch it on. Does it complain? It doesn't complain. But it doesn't make any noise. And yeah, it didn't start. So let's take the circuit from this thing. Let's take it out. Let's take out, yeah. You can completely keep everything. We don't have to remove the circuit. So these are all self-tappers. This is weird. So this is really a really powerful motor. I didn't expect it to be so large. Maybe I can keep it if it still works. We'll see. I think the motor has an issue. I don't see how... let's switch off. How this could have an issue. This is just a ceramic element. I don't think it breaks so fast. So... tabs again. Plenty of tabs. Tabs are cheap. Up. Here we have the main thing. And this was held back by these screws. So now we can switch it on and test and see what works or what doesn't work. These screws, what were... I already lost 2 screws. Ah no, these are for the button. 1, 2, these are not the same format as the other one. So, up. Let's put it somewhere where you can better see it. Yeah, now you have a better angle on it. Let's switch on power. Ah, no, switch off. I don't want to touch the circuit too much. Up. Up. So, switch on the power. Ah! It did manage to turn on once. I think the motor is broken. Why does it turn on again? I didn't press power. This is a really bad circuitry. Okay, now if I turn it by hand, if I turn it on, yeah, I think the motor is broken. There's one of the coils which are broken. This is why you can't continue, because it is working partially. When I turn it a bit here, if I switch it on, it is turning a bit. And then it is stopping. I think one of the windings is broken, and this is why it can't turn anymore. So I can't use the motor. And probably this is where there was an earth connection, and it tripped when the motor was braking, was turning down. That would be my guess. We can test it. So here, yeah, using my quick tester, both live and neutral are completely disconnected. So I can touch, everything is grounded still, but live and neutral are completely disconnected. So we can still work with it. And device, yeah. Damn it. Yeah, I think the motor is broken. Oh, I can feel huge. Oh, there was a tiny piece of plastic. Yeah, there was a piece of plastic inside. I don't know where it came from, or maybe it was just a bread crumble. I don't know. So the motor is probably not that. Let's try again. Yes. It was just a bread crumble, which was stuck in the motor. And there are plenty which are still falling. Oh, no. This is not bread. This is something else. There are plenty of green parts which are falling everywhere. Maybe it is bread. And the bread motor was holding it back. Let's switch off. This was it? Yeah. That's all. Let's switch it off. Okay, now it's off. I don't know why it would have caused... Maybe it didn't cause... no, the RCD tripped. But maybe the RCD also has a 16 amp fuse, and maybe this tripped also, the 60 amp fuse. And no, I tested it also with here, and this tripped. So the issue was really there was a leakage, but it came from the motor. The motor is not looking good. Not at all. Let's open the motor. Let's disconnect this. This is disconnected. We should be fine. Let's have a look at the motor. I see lots of... No, these are not only bread crumbles. This seems to be something more than that. I mean, these pieces here, I don't think this is just bread. They're a bit everywhere. But something, so there was, at least there was a mechanical holding back of the motor. Now the motor turns whenever I force it, and I saw some of these green particles falling. So I need another mat. Where's the pen for that? The pen is here. So bottom cover. These are these 4 screws. Up, bottom cover. Then we have ceramic holder, heating element. Heating element holder. This was this screw. Then we have the front panel holder. So now I'm sorting the screws. Normally this is I do taking apart things for a living, and to find out where the things were, I have this mat where I write what was here. Front panel. Up. This was holding the front panel. There were 2 of them. Up. Then we have the basket. And these were all these screws. Up. Oh, I lost the screw. Up. Here. And this way I can find out again where all the screws were and put it back together, because some clients want the devices back, which is a shame because it makes everything harder. But hey, if it's their wish, it's up to them. So generally when I take apart a device, I ask for 3 pieces. One I can completely destroy, one which can be returned back where I do the actual software reversing and so on, and one just spare because you never know. I can play with it without fearing that it is completely gone. Up. And still it's good practice to know where all the parts were. And now, yeah, we have a new case, which is the base holder, which is just the base, and all the screws, at least all the screws are the same here. Up, base. Though it can be super hard, so I did expect a huge motor, but I didn't expect something like that. This is really big. I hope this is earthed. Yes, it is. We see a earthing tab just there. We'll also have a look at the electronics. They seem rather simple, but we'll still have a look at them. Yeah, all the screws are also the same. There's a huge... I know what it is for. I'm not sure if you can see it. No, I'll show it afterwards once I've opened the base, but there's a huge capacitor, and I think this huge capacitor is to compensate for the motor because it has a huge winding, and maybe they want to do some power factor correction, or maybe it's just to not trip anything. I don't know exactly. I'm not good at AC design. But we will have a look at this capacitor. Come on, screw. Yeah, everything is off. This is fine. There's double safety. The power plug is off and the tester is off, so I should have nothing to worry about. And there is one screw still holding it. But it's not this one. Yeah, it's this one. How to yeah, I can unscrew also the electronics. And I think I have to, because I cannot remove one of the other screws. So let's unscrew the electronics. Electronics holder. Electro holder. Electro holder. Up. Okay. Oh, there are plenty of protections. I'm not sure if it's all protections, if it's sensing. Up. Let's remove. I have to remove this screw because I want to see what's underneath and to see what's happening with the motor. Okay. Ah. Okay. So all the green things here, this was the belt. So the motor is fine, and there was still something stuck, but maybe there was something, because it got transported, this device, and maybe some of this green thing landed in the motor. So it was the dust from... Oh yeah, ooh, it looks really ugly. Yeah. What is this here on the bottom? They turn. Why is there some wire in here? Was it to make it bigger? This is crumbling apart, so this won't hold for long, so I can't use the machine anymore. I would have to change the timing, the belt, and the belt probably costs more than the complete machine. And this was changing fast turning into not so fast turning, because this is larger but has more torque. But this looks really weird with all the wire in between. Okay, this is from here. Maybe one of the wires from the belt just got stuck here and turned around. Blah. Yeah, the belt is gone. So I think the motor is still working fine. And it was just stuck, and maybe there was just too much current which was drawn at one point and it stripped something. Maybe. Can we remove it? Do we want to remove it? Yeah, we want to remove it. We'll never use it again. So this is for sure. This is not worth. This is beyond economical repair. But we'll still continue opening it for the fun and see how things work. So here there is a screw. A nut. I do also have the proper things to turn nuts, but I'm too lazy to get it out. This is faster, and this would probably be sufficient. And I only see one nut. It was well turned. This is a nut with a anti-slip mechanism. I'll show it to you once it is off. It is still hard to turn. Here, you see this black ring on top? This is something so the screw doesn't slip. If the camera would have made it, yeah, this black thing so the screw doesn't, so the nut doesn't turn. Let's get rid of this belt. Up before it puts even more things inside. Now it's turning freely. What is holding you back? there's another sort of this, I don't know how they're called, these washers, which are broken, so somehow when you press on it, they try to make it not slip. I'll show you. So I've moved it. Here, it's a locking washer. I don't know. I'm also not good at mechanical stuff. This is still nice, injected. I mean, you would have to create a new belt, but which we won't do. And now we have this piece. Ah, there's something else which got removed. Yeah, this is not worth salvaging. Oh, although there's a... No, there's nothing worth salvaging. Ah, here, yeah. Here you see it is flat, so here it is round, then it is flat, and this flat was turning this screw right there. So this was the... Is it called key? Well, this is the key for that. Let's still take it apart, just because we can take everything apart and it helps us gain experience of taking things apart. Here I have to open this kind of clip, retention clip, and for that I do also have this thing. So let's turn it and let's try to open the retention clip. And this thing is the right tool, but it is too large. Yeah, doesn't fit. No, okay, it does. Okay. It did fit. Come on, retention clip. I want you away. The construction is not too bad. The belt is probably not the best material. Okay, retention clip gone. Now the retention clip should hold the screw, doesn't it? Yeah. Up. Up. There's a bit of plastic. So this is what was turning the dough turner. I don't know. And now we can even remove this. There is a bit of bread inside here. It's been used a tiny bit of times. Up. Up. This way we also salvage screws, although I'm probably sure I will never use these screws. I do have a box with a lot of screws. Okay, let's open. Up. What is this for? Ah, here, this sort of silicone was so there's kind of this is I think where is this basket here, this basket, and I can still use this basket actually to make things because this is heat resistant. So yeah, this would hold in a cushion, a small cushion. Whenever you lock it, this I think it's probably silicone rubber. Up. So it holds tight. Okay, this is gone. We have also 3 black things which fell from somewhere, but it only seemed to be spaces. Nothing that important. Next part. So yeah, the machine, the issue of the machine was that one of these crumbly belts, when the machine was transported here, fell into the motor, and this locked the motor, and I think, what is this huge screw? Cover. And this caused, I think, too much current, probably, and it. Okay. Can I remove all these things? A fuse. Okay, these are all fuses. Hot. Okay, these are not only fuses. Generally, I take pictures before I take apart, so I know where all the connections were. But this here, I don't have. I don't need it. Ah, okay. Fuse. Okay, now I get it a bit better. Let's open this. I'll show you in a couple of seconds. All the parts. This was for capacitor. Cap. So let's turn this thing around so you can have a better look at it. The sun makes really harsh shadows. So this is the electronics. We have several things here. RT. Okay. So here we have, this is to sense the temperature. This is probably, yep, this is probably a resistor. So RT often stands for resistor thermal. So using that, it would figure out the heat of the inside of the chamber, because this whole metal piece would heat. And we have two fuses, 1 and 2. I don't know why they put 2 fuses. Maybe for different temperatures. I really don't know why 2. 1 should be plenty sufficient. Maybe they must put 2 fuses. Let's open the fuses and see if it's the same temperature. If it's the same temperature, it means that it's just double security, which I find weird. But we'll figure it out. Up this, yeah, okay. But I don't know why they didn't solder. So normally here you see it is, the cables are crimped instead of soldered on the leads. Maybe it was easier. You generally do it for fuses which are heat sensitive, because whenever you heat, well, the lead of the fuse, you break the fuse because the heat goes into it. Oh, this is nice silicon rubber. And here we just have a, I think it's a Schottky or Schottky, I don't know. It's a diode. I know it's this is a diode, and actually by measuring the current which goes through it, you can measure the temperature. This is very often done on heating things, and for example, induction plates also use that. So here we have the 2 fuses. Are they the same value? If they're the same value, it's just double the security. So this is, here, this is what I meant. You see, this is a fuse, and on the fuse, you never solder the leads. You crimp the leads on that, because whenever you solder the leads, you often reach the temperature of the fuse and it breaks it. Here the temperature is, so it's for 10 amperes and 157 degrees Celsius, which is a very common, 152 is a very common fuse for kitchen appliances. And when a kitchen appliance doesn't work, it's often because of that. Yeah, and it's the same, 157 degrees. So it's just double protection. Are they in series? Let's have a look at the electronics. So here we have 2 fuses. And then the last one, this huge connector, this is for the heating elements. And what is the ohm of the heating elements? So up, let's measure ohms. Let's have the wires. And it is 100 ohms. Meaning with 230, we have 230 watts. No, it's 500 watts. Let's check what's written on the bottom. 600 watts. So 230 is for AC waveform. Come on, 1, 2. So we could reuse the heating element. I have no use at all for any such large heating element without the right container for it and the right protection. So we'll get rid of it. Let's unscrew it. Did the heating element have a leak? I don't think so. We will test. Maybe this was the issue. Yeah, it broke down. So here we tested 100. Normally between here and the outer shell there should be no connection. There is a tiny bit, 10 mega ohm. I think that's okay. It's not considered as proper leak. Yeah, it's just too high. So no, there was no short between the inner and the outer. So the heating element is fine. You could reuse the heating element. We won't reuse it, but you could. How is this crimped on it? But here you see, it's like there is a screw in the bracket. Maybe they. I don't know how they do that. Do they just have a pliers which force holding it together? It seems to be you just put the ceramic element here and probably they have some leftover metal which they really press hard on it so it holds the heating element. Okay. And here's the motor. So what I meant here, you see this super large capacitor which is there for the motor. 4 microfarad, 450 volts. More 4 microfarad is really a lot. And what's on the electronic? Oh, I thought the electronics, the microcontroller was here, but it isn't. The microcontroller is actually in here with a 1-layer board. This is kind of unexpected. So here we have 230 inputs, and what's the output? 55 milliamp. What the hell? It uses up to 55 milliamp, but what's... Can you use coils where you specify not the output voltage, but the output current? Huh? I wasn't aware of that. So yeah, AC in, AC out. Yeah, this is where we see it. Let's check. Camera up. Let's put the camera a bit above. I'll wiggle a bit up. So yeah, here we have AC in, the 2 large wires, these 2 large wires, and then we have AC out, and just after the AC out we have a bridge rectifier using 4 diodes, full bridge rectifier, and probably it goes, this is probably the voltage regulator right here, this is the annoying beeper, and this is just for voltage regulating. There's a small input capacitor for the AC, so yeah, AC is coming in here, in there, and here is a small input capacitor. There are also 2 resistors. I probably think these are used as fuse. We'll have to take things apart to figure it out. Up. Okay. So these are the windings. Yeah, H cap. For the H bridge, because it can turn on both directions. Yes, I think it can. So we don't need these things anymore. There is a motor with 3, maybe is it earth and then the 2 sides? It should have, yeah, and as it was blocked, I don't think it is turning both sides. This is probably just earth. Let's check. Check the electronics. Let's remove this board. We can completely unconnect power We'll not use it again. Up. Let's disconnect this power. Up, up. So everything is disconnected. Up, earth. Earth is only connected to the chassis. So this wasn't earth. So the circuit wasn't earthed. And the motor is earthed using the chassis. Up. Base earth. And heating elements. Base earth. Heating. Heat elements. Heating elements. Up. There's about these two screws. Ah, this was for the fuse. Fuses. Up. Plenty of different screws. We can keep this wire. So let's also unscrew the motor from here. I will keep the motor. It seems fine. And it seems to be a powerful motor. But why does it have two? Up. Why does it have two connections? Can it really turn on both directions? In both directions? I don't know. We'll check it out. Up. These are plastic washers. This is weird. Up. 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 Yeah, large metal plate, which I will never use. This is the motor. Let's try to remove this crusty thing. Yeah, I think this was broken from the belt, then got stuck in there really nicely. Up. Okay, so we have a motor. We'll have a look right after it. This plastic base, we will keep this cable, because sometimes I do build things with wire, with mains wire, and this seems to be quite okay mains wire. Up, up. Up. And then just of habits. I'll just make AC cord. AC cord. These are these things. Up. Then we have that's AC cord, and we have motor. Up. Which were these screws? Motor. Okay. Up. There's plenty of strain relief. Oh, that's fine. Maybe too much. Ugh. It's crusty. My bench. I have to clean my bench again. Up. Up. Yeah, I think if it's at H-bridge, it probably turns both ways. Okay, we have an AC cord. Up. That's garbage. I think which is garbage goes here underneath, and then I'll dispose of it correctly. So this, let's have a look at the electronics. Let's try first to remove a tiny bit of the dirt. really a mess. Up. So here the electronics, AC in, AC out, we have the fuse. So there were two fuses. I wonder if they were in series. AC board, AC up, that goes here. And there's still a third screw. Plenty of transistors to turn on and off. Oh, I see something here. Here there should be an electromechanical coil, but they didn't put it here. They just have a jumper wire. They skimped on it. 2006. This board is from 2006. So are the two fuses in series? This is AC in. It goes to one fuse. That's, yeah. Ah, you even have the seal screen on the bottom. Wow. On top and bottom. One fuse, then it goes to the capacitor, to the motor. And then there's either this side. Where does this side go? This is also the capacitor. Ah, that's weird. But it's only the capacitor. It goes nowhere else. Maybe this is to discharge. Whenever the motor is off, it discharges to the capacitor. I don't know. I don't know what this last wire is. Because it goes... So one side of the motor goes to the capacitor, and then the phase goes to the capacitor. So there's one leg which is just for the capacitor, which is between white and red. And white and red is only for the capacitor. I don't know how this motor works. This is a 100-watt motor, okay. And on the bottom, yeah, on the top, this goes nowhere. This is just for the capacitor. So yeah, it goes through the fuse and then through what should be here the relay, which is not the relay anymore to switch on and off the motor. It's just a jumper wire, which goes through this thing, which is a capacitor. Again, there's a capacitor, class Y capacitor. I think class Y, is it this? Class K? I don't know. One of X2, yeah. An X capacitor. Then plenty of other electronics. These are resistors, are probably just to drain the capacitor. But it doesn't. So here there's another fuse, but this fuse. So this is no. Yeah, here's the other fuse. The other fuse is only for this part, for this relay. Here we have a relay, and this is the heating relay. Okay, this is weird. It can't be. How do they switch on the motor? They don't have a relay here, so they cannot switch on the motor here. This is all the time connected. And you need, here it is. This thing, BT137, which I thought in the beginning was a voltage regulator. I think this is a triac. BT137, it's probably a triac. Let's have a look. Let's have a look here. BT137. Yeah, all data sheet I don't need here. Triac, yes, this is a triac. Triac. Okay. So they do control probably the motor. Yeah, the motor. This is, you see here, it goes. The light outside is so harsh. Normally in Berlin there is no sun, and today there's plenty of sun. So here it goes here, and then it goes to the inside of the triac, of this triac. So the motor is controlled using a triac. And the heating element is controlled, here you see hot, is controlled using the using this thing. This is probably because the heating element uses a lot more power, and you don't have to regulate really how much. You don't have to regulate the phase. I mean, you just put power on it, and if in 3 seconds it is okay, you can switch power off, but generally it takes a lot of time to heat things up, so you don't need to switch really fast on and off. The Triac did switch fast on and off the power, so you can better control it, because if you would, you've seen it try to make click, 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 and every time you want to turn on and off, you would have to ignite the coil, initiate the coil, and the coils only last for a certain number of contacts. I think 1,000 contacts, 10,000 contacts, probably depends on the coil. But that would wear out really fast. And just for heating, for example, bread, you probably turn it out 3 times, 4 times, and not 100 times. So you can use that. Draws a lot more current. No, it can let a lot more current pass without heating up, and you don't have to switch it on that fast. But if you want to switch on fast and don't have a lot of current, you use triacs. This is the triac they have here. So what is our voltage regulator here? They don't have one. I think they just really use whatever is coming out of this transformer. 55 milliamps max, but I don't know how much is coming out, and just feed the electronics with that. So the electronics, so this is almost all the board does. And this capacitor is for the motor. Is it? Yeah. This capacitor is for the motor. So they didn't skim, probably, I don't know if they probably, this was probably a safety to really turn on and off completely the motor. In case the triac burns up, you still have a second control, because triac tend to, maybe, I don't know, if I'm not too familiar with triacs, maybe they close on when they are shorted, or when they are broken closed, so all can go through, and here this relay would have prevented this measure. But the relay is too expensive, so they didn't put the relay, and they thought it was nice enough. And as we've seen, the limiting factor is not really the motor or this triac. The limiting factor was the belt. That's all the electronics. Let's take apart this. I'm still wondering. Yeah, I don't know enough about transformers. I'm just wondering how much. What is the voltage going out of this? We could try it, but I think I'll never use it. Although an AC thing would be nice. We will try it out using the quick tester. 1, 2, and 2. Up. So this is the board. We could salvage the relay. No, triac are not expensive. The relays are a bit more expensive. We could salvage that. Capacitors, we don't care. The buzzer, we don't really care. Plastic here, we don't care. We can get rid of this electronics. And I have enough relays lying around. So the motor. This is the motor. This is 100 watt. It has 3 connections. And again, one seems apparently to be only. It's an AC motor. Yeah, 230 watts. It's an AC motor. And one only seems to be for. Let's check out if we can find reference. 4 amps. 4 amps? No, I don't know. 30 turn maybe. So it's YDM 30T. Is it a standard motor? 4A. Ah, breadbed machine repair. Apparently, yeah. Let me show you. And if I put the reference motor, the reference of the motor, one of the first results you find is breadbed machine repair. I think I'm not the only one which has this issue, and it looks very similar. Breadbed machine. Bread maker machine. But I want to have a reference with them for the motor. Everything is in Spanish? I don't know. Motor electronic French that I can read. Why? Yeah. Yeah, so it is just an AC motor, and the other winding, we can measure the windings. The other one was just for the capacitor. Anti-parasitic capacitor or starting capacitor, I don't know. So here we have 0.2 kilo ohm, 100 ohm. Oh yeah, between these two. Yeah, we'll see it on the electronics actually. I think the two outer ones. Where are they? Here, the electronics. No, it goes through the inner one. And if we put it here, the line was going through the inner one, and then the black was the motor winding. Okay. Zero point 0.2 kilo ohm, and then 200 ohm. 200 ohm is probably for the motor, and then the 200 kilo ohm, this was for the capacitor. I still don't know why you need a capacitor on a AC motor, but apparently you do, and a particularly large one. I'll mark it on the thing so I know. Pen on the motor contacts. This was, let's check last time. Yeah, this was H cap. This was the capacitor. This was AC. And then you have the motor turning. Can we try it out? We don't have the electronics to drive it, but we can just connect the pins. And we will. So this was for... yeah, we will try two things out. I want to figure out what's the output voltage of this. And then I want to have this thing turning. But first we will have a look at this electronics. At this board here. Oh, there are two different types of screws on the same board. Who had this idea? Oh, there's even a place for a LED that didn't fit, did they? Yeah, they did. Is this the voltage regulator? Seems to be like this. So what I see from the back here, plenty of resistors to measure. I don't know why so many. This is probably the voltage regulator, or maybe this one. This one. Two capacitors. Here the ceramic resonator. Cheap. Very cheap, but it does the job well enough. So let's have a look. Where is the electronics? These are just the buttons. The resistor are probably only for the buttons. Up. Yeah. This is plastic. Let's get rid of the plastic. So the IC probably doing everything is on the back. Lift the LCD and lift the Mac. Yep, it is. So there's only a single mounted component here. Ah, I know this logo. SH, and this microcontroller does everything. It does the LCD and everything, and it's an SH69P26, and it is coated. See, there's kind of this glare, so it is coated. Let's try to find out what it is. I know this logo. I see semiconductor logos. Here, I did an episode about that. Let's go to S. Let's try to figure out if the logo... No, it's not this logo. It's like Cinewealth. Yes, it's this logo. Cinewealth. Cinewealth, it's... yeah, they do a lot of microcontrollers. And let's try to find out this microcontroller. It's an SH69PM. Yes, Cinewealth again. And we have the microcontroller. Since it's a Chinese microcontroller, the name says it all. Cinewealth. Might be an LCLC. No, but it isn't. 4-bit microcontroller. I didn't know you can make less than 8-bit. Let's have a look. Let's enable scripts, assets. Oh, can I just download here? 4-bit microcontroller. Okay, they put everything on there. And one-time programmable. Cheaper than Flash. And it has an LCD. Yes, external RC ceramic resonator. Here, you can put a ceramic resonator that we see here. And does it tell that it has LCD driver, oscillator, LED, built-in capacitor, channel? I don't see LCD driver. LCD? Come on, I don't care. Just want. Can I download it without logging it? No, I can't. I hate these things. Just want the data sheet. Data sheet. I could go on the Cinewealth site, but I think it's even harder to get anything. Yeah, we don't care. It probably has an embedded. Yeah, it must have an embedded LCD controller, or they are cheating and just alternating AC. Oh, just alternating the DC pins to make that. That could also be the case. But what we will keep is this connector. Up. That's the connector. This goes to electronic bin. And on my table, I have special for electronic trash. That's also electronics, and that's it. And now we will test out these things. This was for the board. This is. I don't use self-tappers. Let's get rid of it. That's plastic. Up. This goes back to where things are, and for that I will not connect it directly to the mains DC, well, the mains AC, but I will do it through my isolation transformer. This way I don't get electrocuted, and the isolation transformer has enough I think it's 100 watts, so I should be able to turn this because this is also 100 watts. We will see. So, crimp. Let's strip the wires. Oh, yes, it's nice. It is, and it's well made. It's double insulated wire. So it's not the cheapest one. For AC, it's good. Okay, so we don't need this plug anymore. We will need this, and we will measure the output here. 1, 2. I do have some crocodiles. Does it make contact? I don't think so. Doesn't feel like it. It's probably not the right leads which I have. No, it's not the right. Okay, so it does work. No, it doesn't make connection. So let's just use normal crocodile clips. Up. Up one side. And we want to measure volts in AC. On the other side. Tack. Knife or neutral is not really important. There is no earth. Tack. Okay, let's switch on the isolation transformer. It is on. And let's turn on this. 15 volts. 14 volts. Okay. That's okay. 14 volts AC. Let's write it down. I don't know if I want to keep it. I don't have a lot of transformers. Everything is switch mode power supplies anymore, so sometimes I might want to use the transformer. Up. 14 volts. So I might probably want to keep that. And now let's try the motor. The motor would be a bit harder because I still want to connect the capacitor to it. There must be a reason for the capacitor. And if it was there in the beginning, I think it has a good reason for being there. Actually, I could keep it. Yes, I don't want to use this connector. I will directly put the capacitor on this device. Yeah, let's do it this way. And this is, it's AC, so it shouldn't be polarized. I don't think so. Do I want to keep the connector? No. I don't want to keep this connector. It's a good AC connector though. I'll keep the connector. Up. Up, and this is not polarized, is it? Don't think so. It is AC, so there's no way it could be polarized. No, it doesn't. This goes here, and probably this goes here. So, yeah. Oh, it's not the right one. Up. 1, 2. 1, 2, and 3. We will connect these ones together, but we also want to connect it to, oh, this is just capacitor. So we could solder them together. But I'll just connect it using fast connections. Up. Things like that. Okay, normally it should be this long. It's half of it, but for testing it will be fine. That's holding together. That's red. Up. The black goes to the white, and we will use a 3 connector thingy because we want an output. 1, 2. 1. 2. And we will have a mains wire coming out. Mains up. I do have some mains wires. Really large core. Actually, could I use this? Probably, yes. We can try it with this kind of thing to turn the motor. Would it work? So this was salvaged from a drill, but I think this thing 5 amperes, too many wires. I think this could be used. What is this? Ah, this is just for the direction. But how will it switch to the, yeah, it's in the switch in the motor. We don't need the thing in the box, but these 2 wires could be used to probably turn the speed of the motor. We'll try it afterwards. For now, I will just use the thick wire, which I just lost now here. Up. Ah, this is not flexible. I don't like it. Not to have something which is a bit easier to use. No, I don't. Ah, this one is a bit easier. Up. 1 and 2. That's solid core. Up. So let's plug it in here. That's one side. That's the other side. Up. And if I turn on, it should turn on the motor. And will it spin really hard? Okay, it can turn without issues. Let's try still to hold it. It turns. It works. It does draw 71, 72. Oh, I don't know why this reading doesn't work, but my isolation transformer tells me, oh, you don't see it turning. Sorry for that. It draws 70 watts according to my isolation transformer. Ah, here we did see in the beginning the rating 2.1 amp. I don't know why it doesn't measure afterwards. Yeah, 74 power. So that works. Now I want to try if it works with this thingy. I think I have another one. Probably it's easier to use. Or is it also with a plug? No, it's also with a plug. Oh yeah, we can put it directly across the isolation transformer. Let's switch it on, off. until I correctly wire it. So this needs a bit more stripping, so wire stripper. Wire stripper, up. Yeah, this we don't use. So up one side must be connected here. Up. I need to strip this a bit more. Tack. And the other side is to be connected here. Oh. No earth connection. Let's put an earth connection. No, I don't need an earth connection because it is an isolation transformer. Else I wouldn't need one, but this is just an isolation transformer. So let's turn the isolation transformer up, doing, and let's try to find out if this works. If it can turn slowly. Yes, it does work. If I press a bit, it doesn't turn fast. And if I press more, it does faster. And this is to limit. This is probably to limit. Yes, it works. It works really nice with that. What is the minimum? So I think that's the minimum. And the minimum draws 30 watts. Okay, it doesn't have a lot of torque. But yeah, it's an AC motor. It doesn't have a lot of torque with the minimum. Let's try with the maximum. Does it have a lot of torque? It has some torque. And I think that the limit is also my isolation transformer. The isolation transformer also is limited. So it works with that. So I'm pretty happy. Let's disconnect, turn off the isolation transformer, up. And yeah, that's it actually. Probably not that interesting. We did find out the issue somehow. Here the motor was stuck, but I can't explain why it did trip the RCD. What do we have in the end? One motor. That's it. Some fuses. Yeah, I will keep the fuses because they're very useful. IC cable and lots of fun. Some new way to use a motor which I wasn't aware before. And that's it. Yeah, it was just a stream to distract myself a bit and to get rid of this equipment, and that's it. Probably next time it will be a bit more electronics related, but until then, enjoy.